First of all, who I am, I'm Pete Loveall, and I am a member of the Texas Interconnect team. Like Mark indicated, we are the pioneers, or actually as the ICOM deal said, the D-Star pioneers in the United States. Bill and Jim, who are the two original founding persons of the Texas Interconnect team, got the first two ID1s in the United States that were not outside of ICOM, or that were outside of ICOM, and we had the first repeater systems, both on 1.2 and also in the VHF and UHF. And in fact, in VHF and UHF world, they were beta test units. And in the 1.2 world, the first repeaters that we had up were RP1, not RP2s, which is what you see in here. And they looked quite a bit different. RP1s are pretty cool for doing things like Go kits. They're really cool for Go kits. Okay, DPRS is the D-Star Position Reporting System. It is a trademark applied for by ICOM. It is an acronym that I coined for them, and the reason I coined it is because I am the developer of DPRS. And last year's proceedings, if you get a copy of last year's proceedings for DCC, you will see a white paper in there that is the specification for DPRS. It is a published specification. First of all, on D-Star 101, it is a protocol that is owned by the ARRL. It means it's not public domain. And it also means that it's not owned by vendors. In other words, ICOM does not own D-Star. It's owned by the ARRL. But it is an open protocol, and it's fully published. And in fact, last night, Robin showed parts of the specification. And if you can read Japanese, you can do a very good job of understanding all the ins and outs of the D-Star protocol. It's very well documented. Unfortunately, being us in the United States, for the most part, we don't read Japanese. And so it has been a little bit of a difficulty trying to understand how it all works. But it is an open protocol, and it is a published protocol. I'm going to put this disclaimer, and I put this disclaimer in all my D-Star presentations. This presentation, we're not going to discuss the, gee, I wish they had, or gee, it would have been nice if, or anything like that. What we're going to talk about is what is, and how you can make use of it. If you want to talk about, gee, I wish, you know, they had done this, or why did they do that, we can talk about that at another time. D-Star Digital Voice, and I highlight voice because that is what it is. It is a voice mode. It is not a data mode. It is a voice mode. Voice is the noun. Digital is the modifier. Voice is the noun. That means that 3/4 of that bandwidth is devoted to voice. 3/4 of the bandwidth is devoted to voice. Now, part of that is forward error correction, such like that, but it's all devoted to voice. And then 1/4 of that bandwidth is there for other things. And one of the things that's specified in the protocol specification is synchronization. And then ICOM added some other things that they could use. The protocol left it open for manufacturers to use it for whatever they wanted to, and ICOM added some other things. ICOM will repeat the RF header in there so that the radios can maybe pick up who it really is at the other end, even if it didn't get the RF header the first time. So hopeful that, well, okay, maybe I can get it later in the transmission and at least know who I'm talking to. Front panel. 20-character front panel message that you can program in. That gets transported over this data area. And also, the ICOM implemented something called basically what we're used to, and that is serial data. I can transmit serial data over it. Key thing here is to understand that this is all in these same 24-bit frames. Okay? So what you see out that serial port, like you were asking earlier, what you see out that serial port is not everything that's going down those 24-bit frames. Okay? And those 24-bit frames, it's 72 bits of voice, 24 bits of data. 72 bits of voice, 24 bits of data. And that's the way it always is. You do not modify that data. And according to the protocol, you are not allowed to modify the data. Something very important. People say, well, gee, what happens if I just replace these frames? The protocol doesn't give you that opportunity. The protocol says, this is the RF header, this is the data, this is the format of the data, you do not change it. If you do, you have now broken the protocol. It's something it's something that sometimes it's very foreign to us because we like to hack. Well, you got to be careful what you hack.
Can I ask a real simple question, Pete? Every time a packet is received, all right, we got our voice, we got our data.
There is no packet. It is a continuous bit stream.
The stream.
It is a continuous stream.
Okay, and it's got 72 bits of voice, 24 bits of data. 24 bits is 3
bytes. Right.
Okay. Are those 3 bytes what's seen on the data port?
No.
Okay.
It is information that is encoded inside some of those 3 bytes. Okay? That's because you have all that other stuff also sharing those same 3 bytes. And so out the serial port, that's not what you see. ICOM has said, we will encode what you put in on the serial port, we will encode it so it can be carried over those 3 bytes. But it's not what is actually carried over those 3 bytes.
So you're saying serial in.
You could do serial in and out.
Well, what do we get out? Serial out.
What was ever sent from the other end, serial in.
3 bytes.
No. Yeah. Let me get back to that. You're trying to dissect it as each one of those things is what you're looking at is saying that each one of those bits, I'm going to see it on the other end of the radio, and I don't. The radio consumes that information and presents it in the way that it is programmed to present it. Okay. So what comes in, if I have a radio and a serial port and I send data in, that data is going to appear at the other end. Now, there may be bit errors and things like that, but that data is going to appear at the other end. If it is received properly and you're using ICOM radios that have properly encoded it so that they understand it. But if you take a look at that bit stream, you'll never see that information because there's other things in those 24 bits as well. It's not, in other words, that serial port on that radio is not a direct access to those 24 bits per frame. It is not direct access, it is encoded access.
What keeps confusing me is I'm only talking about what's coming out of the radio through the serial port, not
what's coming out of it is whatever was transmitted from the other end.
Okay.
What went in at the other end.
Gotcha. Yeah.
Okay? But those 24 bits are always there. Which means that there could be other things in there, which we talked about, which are repetition of the RF header. It could be the message that's going to the front panel. There's lots of stuff in there, but it ain't coming out the other end. The only thing that comes out the other end on that serial port is if somebody transmitted it on the inside, on the import. Okay? That's the only thing that'll come out the serial port. And I'll show you because it is important how that is used. Digital data is an Ethernet bridge. That's it's implemented up on 1.2 gigahertz is 128K. That's an Ethernet bridge. That's period. It doesn't carry voice. Obviously, you can put VoIP theoretically over it, though it's a half duplex transmission. It's not going to work very well. But that's Ethernet. That's an Ethernet transmission. Nothing to do with serial. Okay. DPRS. The definition of DPRS is it is the conversion of ICOM GPS information into APRS format packets. That is what DPRS is. Now there's some other pieces that we'll talk about, but that's the thing to keep in mind. We're taking ICOM GPS information. It's not in the D-Star protocol spec, by the way. It's ICOM GPS information, and we're presenting it and we're translating it into an APRS format. Most of the D-Star repeater gateway implementations have DPRS iGates into the APRS IS world. Most of them implemented throughout the world have that capability. Where you don't have repeaters, that have it implemented, like in Japan, They use something called DPRS interface, which is a software implementation, to do that eye gating into the internet. Or you can, as an individual user, download DPRS interface, install it, and hook up your UI view or whatever you want to, and you can see the GPS information going on. It's what's known as voice with situational awareness. I have a tactical voice net, and I have situational awareness. Every time somebody transmits, I know where they are. And during an MCOM opportunity, that is big.
Isn't that only true if they've got a GPS attached to it?
Well, yeah. I mean, obviously. That's true if the transmitting station has a GPS, yes. Absolutely. That's always the case. I'm not going to know where you are unless you tell me. You got to tell me. So, but the radios, all the radios have that capability except for the ID1. All the capabilities have the capability to hook a GPS up. The 2820 with the D-Star module comes with the GPS. That has a GPS built in. The 9280, you can buy the microphone that has the GPS built in. Okay? Things to keep in mind. APRS is a protocol. It defines a protocol of how you transmit. DPRS is a conversion. It converts from one protocol, in essence, to another. APRS depends on an error-free transport. AX25 has CRC in it, and if the CRC isn't good, then the packet's thrown away. It depends on that. It depends that it's not going to see bad data. Okay? DPRS depends that we have to put some error detection capability into the data stream, because those 24 bits that are being passed along, remember I said that the voice has 3,600 bits per second, basically 3/4 of the bandwidth it's using, okay? That 3/4 of the bandwidth that it's using includes forward error correction. So that at the other end, as it's receiving, it's looking at the forward error correction as well, and it's trying to put it all back together so that you get the real transmission instead of a bunch of garble. You don't get that on the 24 bits. 24 bits are naked. And keep in mind, while that's theoretically 1,200 bits per second, it's not. It's 24 bits interspersed in a 96-bit, and it's bad to say a segment because there's no chop, chop, chop. It's a continuous bit stream. But there is no protection, and that is at 4,800 bits per second. So that means I am much more prone to a bit error than I would have been if it had been transmitted by itself at 1,200 bits per second. Okay? And that's just the way it is, but something people tend to have a time wrapping their mind around is that, okay, yeah, it's 1,200 bits per second theoretically of bandwidth that I'm transmitting through, but it's being transmitted at 4,800 bits per second. It makes it a little more susceptible to bit errors. APRS is based on an interleave channel. A transmit boom, transmit boom, transmit boom, transmit boom. The DPRS is based on a shared channel. As long as I'm talking, I got the mic keyed down right now. As long as I'm talking, you don't get to talk. All right? That's the way it works. It's the way voice mode works. It's a voice communications. So as long as I'm talking, you don't get to talk. Caution on the 92AD. You hook up that GPS mic, you just have told that radio that it's going to talk every 3 seconds. Guess what? Nobody else gets to talk on the channel. Okay? First thing you do when you hook up that GPS mic, you go into that 92AD and you say, quit beaconing. Turn off beacon. It's just the way the firmware automatically connects up to it.
There probably is a situation where you might want to beacon, but
not at 3 seconds. Not 3 seconds a shot.
Can you change the time parameter?
You can change the time parameter, but the default when you plug that puppy in is it's going to go to a 3-second beacon rate, which means that the channel's unusable because it's a voice channel. That means nobody else can transmit. Nobody else can talk. Okay. Same thing with AX25. Same type of deal. AX25 is a digital communication, right? Wrong. It's a digital communication using an analog transmission medium. Okay? You convert it to analog, you use a modem. We don't do that in D-Star. It is digital. It goes into a GMSK, which is a digital transmission mechanism. All right. They are both layer 2 protocols, though a lot of people have tried to make AX25 into a layer 3, which means that they tried to make believe that digipeaters were nodes and things like that. That doesn't exist in D-Star and never will. Okay, it's not part of the specification. And there is no room left open to try to make it part of this specification. Okay. The DPRS specification is the translation from ICOM GPS information, both GPS and GPSA mode, which I'll talk about, embedded in the digital voice data stream. It has bit stream. It has nothing to do with digital data. Okay, that's a different bit stream, different type of bit stream. This is with interleaved within the digital voice bit stream. Okay, and we translate that to an APRS TNC2 type format. Okay. The translation, we can also take APRS TNC2 formatted packets like from UIView or something like that, and we can actually transmit that and use the D-Star digital voice serial. We can actually send that to an APRS client at the other end. And it provides, keep in mind, APRS requires a reliable communications link. It has to be able to determine that there's an error. Well, DPRS says, okay, I will encapsulate that just the same way that ICOM encapsulates their GPSA mode by putting a CRC on it and such, so that at the other end we can take that off and the APRS client's happy. And if it's not right, then we just don't give it to the APRS client. Yeah?
Can you say briefly about the difference between GPS and GPSA?
I will. Yes, I will. Where did DPRS begin? Basically, ICOM came in with these radios. Originally, it was the V82 and the U82 and the 800 had serial ports. At that point, though, we didn't even have the 2200 with the D-Star at that point. They had these serial ports, and I was like, well, this is pretty cool. Okay, and I got a call from Jim McClellan. You saw Jim McClellan in that in Mark's presentation, talking in the ICOM video. And Jim said, Pete, somebody told me that you know something about APRS. Well, I'm the author of Java APRS Server, which is the server software that is used primarily throughout the APRS IS network. Okay. So somebody had thrown that at him and said, hey, by the way, Jim, he's also in your backyard. He's just up the road of about 30 miles, and you can give him a call. So he did. And he said, if I gave you a couple of these radios to test with, do you think you could maybe get them to be able to take a look at this GPS data coming off and make some sort of translation? I said, okay. And I didn't know much about D-Star at that point, other than how to spell it. And even then, I was spelling it wrong. There's supposed to be a hyphen in there. It's all supposed to be caps. I didn't know that. But anyway, he did that, and I got these radios, and I started looking at this gobbledygook that they were sending out. And I'm going, what the heck did they do? And I started figuring it out, and it was actually pretty easy to reverse engineer. And I didn't understand at the time how they were doing it, but bottom line is that if you had one radio in data mode, in other words, not in GPS mode, and you had the other radio in GPS mode, then every time this person started talking, by golly, his GPS coordinates came out, and every once in a while I'd see his call and a message come by, and then his stuff coming back through, and that was really cool. Now, I couldn't use this radio with the GPS because it had to be not in GPS mode for me to see that come out the serial port. It's like, okay. But that gave me how to do it. And I was seeing these GPS NMEA strings, and I saw these call sign message lines where you had call sign, comma, and then, which was 8 characters always, comma, and then the 20-character message that was programmed into what's in the 800 is called C1 message. And I was seeing that come across, and I was thinking, well, that's pretty cool. And I can maybe change the messages. No, it doesn't. This is a one-way deal. The radio's sending it, but it ain't display. The receiving radio is not using that stream that I was looking at to understand for instance, the front panel message. It wasn't using that. I didn't understand why, but the reason why, which I later learned after going into the protocol very heavily for the D-Star Monitor project, that serial data stream, what ICOM said is, hey, we've defined this serial port in, serial port out type of thing where I can transport just standard async data across. That's pretty cool. If I do that, let's just inject, instead of letting the serial data, let's turn off that serial port, okay, so you can't inject into and send out of, hook up a GPS to that same serial port, and now I can encapsulate that, I can send that GPS through that same encapsulation format so that at the other end, I can either have the radio try to interpret it, which on the old radios they didn't. You didn't even know where the person was in relation to you at all. Or I can have it go out the serial port at the other end. If I have it go out the serial port at the other end, since it's just standard serial data, then somebody can write some application software to make it understand what's coming out that GPS. That's where this all came from, is the ability to take these GPS NMEA strings and these GPS strings and these call sign message lines and make them available, and ICOM made them available on the serial port, and I was asked, can you turn that into something that we can make it into something else? And that is, can we make it into APRS? Now, why would ICOM back in 2005 be really interested in having this happen? 2004, 2005 timeframe. The reason is because nobody had written any applications for D-Star. And one of the applications that would have been really nice was to be able to map where people were. And we had a little bright idea of, hey, you know what? A bunch of guys over here in the APRS world already wrote this stuff. Maybe we can just reformat it. We went through a lot of testing, and we found some holes. Let me rephrase that. We didn't find holes. We found some issues, and these issues were things like there was no error correction on this data stream. So we had to figure out, how do you enforce, how do you require that if you're going to want to be seen using your GPS, and you have your GPS hooked up to your radio and you want to be seen, you better program that message exactly how I tell you to. Because if you don't, I'm never going to know that it's you, and I'm not going to allow that information to even exist beyond the local D-Star network. Why? Because then if I do allow it, then I have garbled call signs, I have garbled information, I don't know what's going on. The good thing is the GPS NMEA strings, by default, have a checksum. Every NMEA string has a checksum. So we said, okay, let's put the checksum in the message. And we created that. DPRS was, I was asked to start doing this back in the summer before Katrina. In between Dayton and Katrina, basically, I was asked to do this, okay? After Katrina, needless to say, there was a lot of scrambling by a lot of folks. We were invited, the Texas Interconnect team was invited to participate in a joint demonstration to the federal government of how disparate organizations could interact successfully together to provide communications. That was, and I will say this, that was by the very strong arguments from ICOM that we be allowed to participate. Because the people that had asked for this to be done, which was your FEMA, your military, okay, like the Army and the Pentagon was looking at this and things like that. They didn't want amateur radio involved. They thought we didn't have really a place to play in this game. And from their standpoint, I can understand why. Bottom line is, the requirement was that we had to work with, there were about 6 other commercial groups and an amateur radio group. They pulled up a van, said, you have 20 minutes to be set up and operational. For those of you who don't know, Fred, WB5ERD, Fred is a very large man, and I was surprised that he even fit into the van with all the equipment and everything that was there. Fred had our operation up within 10 minutes. We were waiting on the commercial guys to get their stuff finished. What do we have up? We had up a 1.2 repeater. We had up a 1.2 digital data operation. We were able to demonstrate from that operation, and then we also had 2 meter and 440 up. We were able to demonstrate that we had people within 30-mile radius of this operation being able to communicate. And every time I keyed down, that colonel in the Army saw where I was. Every time he keyed down, colonel in the Army saw where he was. And at the end, he said, you know what? I never thought amateur radio could do that. The reason we could do it, we had D-Star, which was automatically transmitting the GPS information. We didn't have beacons. We didn't turn on beaconing. We had it purposely turned off. But every time Mark would check in, if Mark was down there, by golly, we knew where Mark was. Or on the UI view map, it popped up. That was the first demonstration of DPRS. First official demonstration of it. We continued to refine it to handle bit loss. The tape that Mark has of the guys out in Lubbock is as flat as this table, okay? Which means that as you get out to the edge, you don't fall off. You get really, really noisy, okay? If you go to Palador Canyon, you will fall off. But as long as you stay on this tabletop, you're not going to fall off. You're just going to start getting very, very noisy. And boy, that was a great test bed because he was really willing to work with us, and we were able to really isolate how to get rid of those bit errors. And what we basically did was said, okay, there's two things we would like to have that the standard GPS format does not give us. We want to have a symbol we want people to be able to set their own symbol. Okay, and number two is that we need to have error detection. Well, the error detection, we said, simplest way is let's just do the same checksum that NMEA does. I know what that format's always going to be from the remote end, so I can do a lot of checking against it. And number two is let's go ahead and take a look and since you got to force you to use that put in that checksum anyway, let's go ahead and force you to put in 4 other characters, and you're going to tell me what symbol you want. I made it pretty easy. All right. Continuing on here, the DPRS also allows APRS clients to, for instance, send messages back and forth between each other using the APRS messaging capability, using the D-Star digital voice. Because it's serial in, we're putting a CRC on it so that at the other end they can strip off that CRC and say, yeah, that's valid, and send it on to the client. So APRS clients can talk back and forth. DPRS was introduced into Japan, and within 72 hours...
Is that with an APRS client running the D-Star radio too then?
No. APR, that's with 2 D-Star radios and an APRS client and an APRS client. Those 2 APRS clients can talk back and forth. 2820 does not run APRS. It runs GPSA mode. That's a completely different thing. It does not run APRS. It's a good question, and sometimes it's a little hard to understand because if you take a look at GPSA mode and you look at the description, it looks like APRS. Well, it's not quite. DPRS was introduced into Japan. Within 72 hours, there were more people in Japan on DPRS than there was in the rest of the world. And this was where they had to go out and calculate what the CRC was and figure out what symbol they wanted and put that in their message. So in other words, they had to do something to get there. And within 72 hours, there were more people in Japan on DPRS than there were in the rest of the world of the introduction to it. Soon after, ICOM came out with the 2820. And they had this new thing called GPSA mode. And I was the benefactor of one of the first units here in the United States that was a beta unit. And ICOM sent it specifically to me saying, Pete, our engineers came up with this GPSA mode because of what they saw with the GPS, what you're doing with GPS mode. We want to make sure that anything that's done with DPRS will also be able to encompass GPSA mode. So will you please take a look at it and do it? So in other words, I had one of the first 2820s that I was sitting there decoding what was going on. They kept with their deal of they're going to send it down with the standard serial data. So I was able to take a look at it and decode it. And what they did was basically they took all these lines of NMEA and everything like that and basically put it into an APRS format. Okay, but they have a header and they have a CRC on it, and so you can't just hook an APRS client up to it. You've got to strip that information off and use it. And so the DPRS translators do that. And that's what. And we also said, hey, that's pretty cool. CRC is better than a checksum. We'll use that for our transport mechanism too. Since it's already an APRS format, we can do that. So Java APRS server DPRS interface was updated, and then we changed the APRS to APRS communications to also encompass that. And that is what is published now. That is what's published out in the proceedings from last year. It's also on the APRSIS.net website, which I'll show you at the end here. But that specification is a specification. It is published and has been for over a year now. Okay, this is how to. How do I, if I'm an ICOM radio operator, how do I be seen? How am I seen? Radios in GPS or GPSA mode with locked GPS. Okay, there we go. There should be a comma in there, I guess. Radios in GPS or GPSA mode with a locked GPS. In other words, I have a position, which I would not get probably in this building. But if I were outside, I'd have a locked GPS position, okay? They transmit that GPS information continuously as long as I'm talking. I got a radio, I'm talking. So if you're active on a repeater or something like that, never turn on beaconing. We know where you are. You don't have to tell us again. Okay?
If you want to send a text message through DRATs, can you leave that in? Or?
DRATs is ignored. DRATs is ignored, and you can share a serial port. We do that because the D-Star interface, the DPRS interface software, for instance, creates a serial socket that you can hook up DRATs to and actually do text messaging if you want to do that through DRATs, and also have your APRS interface, your APRS client connected. You can do that. You can do both of them. You can do them simultaneously on the same radio. The reason is, if it isn't followed that GPSA, if it is not in that GPS format or that GPSA format, guess what? It's ignored. We don't even do anything with it. The other problem with this serial port output is there's no identification. Okay? Other than what's actually physically in the stream, I don't know it's you transmitting on the serial port. There's nothing to tell me on the serial port that it's you transmitting. All right? So that's part of what the GPS and GPSA protocol does, is it does tell me who it is that's built into the radio to transmit your call sign as part of that text. Part of DRATs transmits that as text. Okay? That's how the DRATs at the other end knows who's transmitting. It's not because it's getting it from the radio, it's because it's getting it from the software at the other end that's telling it who it is. All right? So you're not getting the RF header information that's being displayed on the front panel and everything. You're not seeing that on the serial port. What you're seeing is whatever somebody on the other end is transmitting to you. Okay?
The other thing you mentioned is where this information goes depends on the radio program, whether it's simplex or repeater to repeater.
Right, and I'll talk about that here in a second. Keep in mind the frequency is shared and not interleaved. Never, ever, ever on a D-Star radio beacon more than every 5 minutes. Okay? It ain't APRS where you can maybe get away with a lot of condemnation at every 30-second beacons. It ain't going to work on a D-Star frequency because they're using it for voice. And that is what the protocol is for. Okay, how to in a GPS mode. Connect your GPS to the radio. If it's a 2820, you already got it connected. It's inside. Configure the GPS. In some of the older radios, it's called the C1 message, according to this website, this web page right here. It's really easy. You put in the call sign that you have programmed into the radio. You pick which symbol you want. You put in, if you want any extra text in your message, you got 20 characters, of which 6 of them are basically being used. So you still got 14 characters. You can put something in that message if you want. And this thing will automatically calculate it for you. The only thing is you must have JavaScript enabled. Okay? It does require JavaScript to do it. If you're using a repeater, set repeater 1 to the local repeater. Okay, that's what you're supposed to do anyway. Set repeater 2 to the local gateway. Even if you're going to just talk locally, still do that. Because anything that goes through repeater 1, what's going to go through repeater 1, everybody in the local area is going to hear anyway. Okay? Most importantly, set your call to CQ, CQ, CQ. If you have it programmed into your radio that you're going to talk to so-and-so over here, and you leave it that way, guess what? Everybody over there, the next time you transmit, the next time, if you have it set for beaconing, whoever's at that remote repeater location is going to see you too. And they don't want to. Okay? They don't want to. So keep your beacons. If you're going to put it on beacon, make sure, darn sure you're talking locally. The reason you have to have RPT2 set to the local gateway, which is the repeater call sign with a G as the station ID, okay, that 8th character is a G for station ID. The reason you have to do that is that the software that is running to do this iGate function is running on the gateway. And if you don't put that in repeater 2, the gateway never sees the bit stream. You'll hear Robin talk about D+ and being able to listen in on all the repeater activities. Well, that's not really true. You get to listen in on all the repeater activities of everybody that has the gateway programmed into repeater 2. If they're local, you never see it. Why? Because his software also runs on the gateway. And you got to tell the repeater controller that you want your bit stream to make it to the gateway. And once it makes it to the gateway and it sees CQ, 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 it goes... doesn't do anything with it, okay? That's fine. Because all our other software, like Robin's D+ and D-Star Monitor and such, is saying, ooh, I got stuff. Sending it, and then you got the iGate going on to send it in, and if it's GPS information, all that kind of good stuff. So it's pretty effective. Yeah?
The original DPRS software needed a client radio listening to frequency,
Yes.
But now it runs in a gateway and listens to all the voice modules.
And still, you can get the individual. You can still have your own DPRS interface software so that you can run your own APRS client without any internet connectivity and see where everybody is. And that's what they do in Japan. They do not have any of this DPRS software on the repeaters at this time. It's all done through individual stations monitoring. GPSA mode. This is what was introduced after Japan saw what DPRS was. On the 2820, it is very important. The manuals are really deceiving. Now, 92 is better. The 2820 manual, when they came out, they really didn't understand what they were doing. They just sort of had a pretty good idea. They read the APRS spec, and of course, Japanese to English, English to Japanese was a little bit iffy, and so they weren't quite sure. And so it starts off with this being blank, and they sort of give you an example that is not what you should use at all. Actually is a bad thing. Their example is a bad thing. These are the formats you must use. The 92, I think, comes now pre-programmed so that it's API 92, D* asterisk. That's fine. All this first one is saying that it's APRS, ICOM, and a radio identification. Okay? That's all it is. This one's very important because this is saying that it's coming from the D* network. And the asterisk is important here because that says that's where I heard it. This last place I heard this packet come in was on the D* network. So that's very important if you're using GPSA mode. Okay, in GPSA mode, just like in GPS mode, first you have to have the GPS connected. And the other thing is that You want to set the repeater 1 to the local repeater and repeater 2 to the local gateway if you're using a repeater. If you're using simplex, you don't set those. You leave those blank. You always set your call to CQ, CQ, CQ unless you're specifically calling somebody.
What is the unpronto parameter?
That's what it's called. I mean, that's what it is in the radio. The unproto is, and this is what this does, is it creates a part of the path.
It's a parameter in the radio.
It's a parameter in the radio. It's a parameter in the radio. That's why I use it. This is the word they use for the parameter. When you bring up the menu, it says unproto, and you set the unproto. That's why I personally wouldn't have used it exactly that way, but I know where it came from.
Packet use that usually.
And it's actually got a little bit confusing because of it got misinterpreted in the APRS world a little bit. It got and not just the APRS world, in a lot of areas as to what unproto really meant. But that's the word they use, so that's the parameter that you set, and that is what ICOM calls the parameters. How to connect an APRS client. Okay, now those are you set up in GPS or GPSA mode. And those are, you select that in the radio. The 92 and the 2820 right now are the only two radios that have GPSA mode. The rest are GPS only. With an APRS client, you'll connect that to DPRS interface or to Java APRS server. Now, why Java APRS server? Java DPRS interface is simply a Windows GUI wrapper around Java APRS server that only does DPRS. Okay? Java APRS server is the server software that's running APRS IS, the APRS on the internet system. That is the server software. Okay? It's just a Java. It's Java. So I can run it on anything. I put it in a Windows deal because most people run Windows. Hey, you can get your APRS client. Everything's pretty cool. Comes as a self-installer. It's really nice and clean. Java APRS server ain't that clean. And that's why the asterisks there. If you want to use Linux, to get Java APRS server, you must contact me directly via email. And I will provide you with Java APRS server and a sample configuration file for the use that you want to use it for. It's not as simple because it has lots and lots and lots of options. Okay? It's easy to configure and it's easy to mess up because it has so many options. All right? But it's all Java, so even if you're using Apple, Linux, Unix, whatever, if it's got a Java, if you've got a Java interface, you can pretty well use it. Well, yeah, but on Windows it doesn't matter because Windows uses .NET.
Okay.
Windows uses .NET, and the installer will make sure that you have the right version of .NET installed. You configure DPRS interface and APRS to use the same call sign. Now, remember what I said, that 8th character is a station ID? Well, what we do then with APRS, with DPRS is that we put a dash in front of that character. If your call sign is 7 characters, there is no dash. And I'll make it a total of 8 characters. And that's just because of the way ICOM did it with the GPSA mode. You set the radio to data mode, not GPS mode, but to data mode, because it's your APRS client now that's going to be doing the DPRS stuff, not the radio. And then you feed the GPS into the APRS client. Keep in mind, frequency is shared, not interleaved. Do not gate APRS onto the DPRS channel. You will have a lot of very upset D-Star users saying, why is my radio continually keying and I can't use this frequency anymore? Okay? And that's basically it. Bottom line, I use this to talk about digital voice, period, in the D-Star world. Real important. It is voice communications with concurrent, reliable, situational awareness. And boy, you talk to the MCOM folks, you talk to the people doing Skywarn like Mark was talking about and stuff, and their net controls can know where people are. And it's not a deal of, well, do they have an APRS tracker? Do they have this? No. Do they have a D-Star radio? Yeah. Do they got a GPS hooked up to it? Yeah, you're set. We're done. I know where you are. We're cool. You checked in, I know where you are. I don't have to ask you where you are. You just talk to me. I know where you are. Okay? I know where you are. I'm looking at it on a map with the radar. I know where you are to that storm. Move! It's great. It does give you APRS to APRS client messaging, but really the key thing is and to be real honest with you, is it's giving you situational awareness. And that's something that we haven't ever had before. It's built in. Any questions? I want to thank you. If you have a coupon for lunch today, it is being held in the atrium, and I highly encourage everyone to move on down there before the rest of the crowd gets there.